Good morning, students. Our lesson today is statistics. But before we start explaining our lesson, we have things to remember that you have been studied in Prep 3 and Prep 2 and Prep 1. The mean of values. If we have the ages of 1, 2, 3, 4, 5, 6 persons, their ages are 10, 12, 18, 8, 9, and 3. The mean of their ages, or the mean value of their ages, equal the sum of their ages divided the number of persons. So if you want to get the mean of their ages, we will add 10 plus 12 plus 18 plus 8 plus 9 plus 3 divided the number of persons, which are 1, 2, 3, 4, 5, 6. Then the mean value of their ages equals 60 divided 6 equal 10. Second, the median. If we have the ages of 1, 2, 3, 4, 5 persons, and we want to get the median of these values, we are going to arrange these values either ascendingly or descendingly. So the values after arrangement is 7, 8, 13, 15, and 60. The median is the middle value, which is 13. So the median of this set of values equals 13. For example, if the order of median of set of values is the ninth is the order of median, then the number of values. The median is the ninth. This means that we have 8 values before 9 and 8 values after 9. After the 9th, then the number of values is 8, 8, and the 9th is 17 values. Then the number of values is 17 values. The mode of values. If we have the set of values 6, 9, 7, 6, 5, 7, 8, 6, the mode of these values is the value which have the highest repetition or the most repeated value. The most repeated value is 6. Then the mode of these values is the number or the value 6. Mean, median, and mode, lessons that have been studied in Prep 1 and Prep 2. Now we are going to start explaining our lesson, which is dispersion. Dispersion. What's the meaning of dispersion? If we have 5 persons, their ages are 12, 15, 11, 14, and 17. Dispersion. What's the meaning of dispersion? Dispersion is the difference among values. The difference between their ages 12, 15, 11, 14, 17 means that the difference between their ages is little. Little, this is called little dispersion. Then the difference among the values 12, 15, 11, 14, 17 is little. But if we have the values 15, 20, 35, 48, and 10, the difference among these values is greater than the difference among the values 12, 15, 11, 14, 17. This means that dispersion in this case is greater than dispersion in the first case. So in the first case, we can say that dispersion is little, but in the second case, we can say that dispersion is Great. So dispersion is the difference among the values. Whatever the values are, the difference between ages, difference between weights, difference between marks of students, difference between wages of some workers in a factory. So dispersion is the difference among these values. Dispersion. Dispersion is measured by one of two ways. The first way, or the first method for measuring dispersion, is the range. The range. The range, if we have the set of values 16, 28, 34, 12, 46, 59. We can measure the dispersion by using the range. The range is the difference between the greatest value and the smallest value. So we will get the difference between 59 and 12. We will say that the range equals 47. The range is the simplest measure for dispersion, but the range is not an accurate method for measuring dispersion. It's not an accurate, but it's the simplest measure for dispersion. Again, the range is one of the ways for measuring dispersion. The range is the difference between the greatest value and the smallest value. So we can say that the range equals 47. We have to know that the range is the simplest measure for dispersion, but it's not an accurate measure for dispersion. The second measure of dispersion, or the second method for measuring dispersion, is called the standard deviation. Standard deviation is symbolized by sigma. Sigma is the symbol of standard deviation. This letter is called sigma, is the second measure for dispersion. The standard deviation, sigma, is the accurate measure for dispersion, is the accurate measure for dispersion. So the range is not an accurate measure for dispersion. The range is the difference between the greatest value and the smallest value. The range is the simplest measure for dispersion. Now we are going to start explaining standard deviation, which is the accurate measure for dispersion. The standard deviation sigma for set of values, we have the set of values 23, 12, 17, 13, 15. For example, these values represent the ages of 1, 2, 3, 4, 5 persons. The ages of 5 persons is 23, 12, 17, 13, and 15. How can we calculate the standard deviation sigma, which is the most accurate measure for dispersion? We are going to use the rule sigma standard deviation equals square root summation. The symbol is summation. Summation of x minus x dash all power 2 divided by n under the square root. Sigma equals summation x minus x dash all power 2 divided n. Let's start explaining what's x dash, what's n. X represent the values which are the ages of the 5 persons, x, x, x. What about x dash? So x is the value. What about x dash? X dash is the mean of these values, the mean. So we'll start getting the mean x dash. X dash equals the sum of values divided the number of values. 23 plus 12 plus 17 plus 13 plus 15 divided their number, which is 5. Then x dash equals 60. After getting the mean of values x dash, we are going to set the table like this. The table, the first is x, the second digit is x minus x dash, the third digit is x minus x dash all to the power 2. So we'll start setting this table. X, as we said before, the values 23, 12, 17, 13, 15. X minus x dash, we are going to subtract x and x dash. Subtract x, 23, minus x dash, 16. 23 minus 16 equals 7. 12 minus 16 equals negative 4. 17 minus 16 equals 1. 13 minus 16 equals negative 3. 15 minus 16 equals negative 1. We are going to block this digit. Then we will get x minus x dash all to the power 2. After getting x minus x dash, we are going to square 7. 7 squared. 7 squared is 49. Negative 4 squared is 16. 1 squared is 1. Negative 3 squared is 9. Negative 1 squared is 1. This is x minus x dash all power 2 digit. Then we are going to start summation. We will add 49 plus 16 plus 1 plus 9 plus 1. Then the summation of x minus x dash all power 2 is 76. Again, calculate the mean and the standard deviation of the set of values 23, 12, 17, 13, 15. At the beginning, before getting the standard deviation sigma, we are going to get the mean of these values. The mean of these values, 23 plus 12 plus 17 plus 13 plus 15 divided by 5, then the mean x dash is 60. This is the first step of getting the standard deviation, x dash equal 16. Then, after getting the mean x dash, we are going to set the table x, the second digit is x minus x dash, the third digit is x minus x dash. After getting x minus x dash, we are going to square it. Square. X, 23, 12, 17, 13, 15. X minus x dash. X minus x dash. 23 minus 16 is 7. 12 minus 16 is negative 4. 17 minus 16 is 1. 13 minus 16 is negative 3. 15 minus 16 is negative 1. Then we are going to start squaring these values. Square 7 is 49. Squaring negative 4 is 16. Squaring 1 is 1. Squaring negative 3 is 9. Squaring negative 1 is 1. Then we are going to start summation. We will add the values 49 plus 16 plus 1 plus 9 plus 1. The final answer is 76. This is the summation of x minus x dash all to the power 2. So after getting the summation of x minus x dash all power 2, we are going to get the standard deviation sigma. The standard deviation sigma, applying this rule, equals summation x minus x dash all power 2, which is 76, divided the number of values, which is 5. Then the standard deviation is square root 76 divided 5, approximately 3.9. Then the standard deviation of these values, which is an accurate measure, approximately 3.9. This is the standard deviation for set of values like 27, 12, 17, 13, and 15. Now we will get the standard deviation for frequency distribution. Look at this table. This table represents the ages of 10 persons. Their ages. We have one person, his age is 5. Two persons, their ages 8. 3 persons, their ages 9. 3 persons, their ages 10. 1 person, his age is 12. This is called frequency distribution. How can we get the standard deviation for frequency distribution? Frequency distribution is the table, which is 5, 8, 9, 10, 12, 1, 2, 3, 3, 1. The total number of students is 10. How can we get the standard deviation of the set of ages of these persons? We will get the standard deviation of their ages by another rule. Let's start at the beginning. We say that the ages represent the symbol X. The number of persons represents the symbol K. Then X is the ages, K is the number of persons, or we say it frequency. X and K, age, number of persons. How can we calculate the standard deviation for the frequency distribution? We are going to use these rules. The first rule of getting X dash, the mean of these values. The second rule for getting the standard deviation. First of all, we are going to get the mean X dash. To get the mean of the set of ages of these persons, to get the mean, we are going to set the table X, K, X times K. This is the table, the first table for getting the mean. To get the mean X dash, the mean X dash equals summation X times K over summation of K. We will set the table XK, X times K. X, 5, 8, 9, 10, 12. K, frequency, or the number of students, 1, 2, 3, 3, 1. The third digit is X times K. We are going to multiply X by K. 5 times 1 equals 5. 8 times 2 equals 16. 9 times 3 is 27. 10 times 3 is 30. 12 times 1 is 12. Now we are going to get the summation of x times k. The summation of x times k, 5 plus 16 plus 27 plus 30 plus 12 equals 9. This is the summation of x times k over summation of k. Summation of k, 1 plus 2 plus 3 plus 3 plus 1 is 10. This is the total number of persons. We will get the mean of these values or the mean of their ages by using the rule summation x times k over summation of k. Then x dash equals 90 divided by 10. Then the mean x dash equals 9. Then the first 3 digits are established to get the mean of these ages, which is 9. Then we are going to set the rest of the table. The rest of the table, x minus x dash. Then x minus x dash all to the power 2 times k. X minus x dash. x5 minus x dash 9 equals the negative 4. 8 minus 9 equals the negative 1. 9 minus 9 equals 0. 10 minus 9 is 1. 12 minus 9 is 3. This is x minus x dash digit, negative 4, negative 1, 0, 1, 3. The last digit is x minus x dash all to the power 2 multiplied by k. Then we will square negative 4 x minus x dash all to the power 2 times k1. Negative 4 squared times 1 equals 16. Second, x minus x dash negative 1 all power 2 times k2 equals 2. X minus x dash 0 all power 2 times k3 equals 0. X minus x dash 1 all power 2 times k equals 3. The last one, x minus x dash all power 2 times k equals 9. We will get the summation of x minus x dash all to the power 2 times k, 16 plus 2 plus 0 plus 3 plus 9 is 30. This is the summation of x minus x dash all to the power 2 times k. After getting the summation of x minus x dash all power 2 times k, we will get the standard deviation sigma. The standard deviation equals summation x minus x dash all power 2 times k, which is 30, divided summation of k, which is 10. Then the standard deviation equals root 3. 30 divided 10 equals 3. The square root 3 approximately 1.7. This is the standard deviation for frequency distribution, and this is the standard deviation for a set of values like this. Now we have some questions. The standard deviation for set of equal values. the standard deviation of set of equal values. If we have 5 persons, their ages are the same. We have 5 persons have the same age. Then there is no difference among their values. No difference among their values means that the standard deviation equals 0. So the standard deviation of set of equal values is 0. We have another question. If summation x minus x dash all to the power 2 equals 48, and sigma equals 4. Then the number of values equals, we have summation x minus x dash all power 2 and the standard deviation sigma is 4. And we want to calculate the number of values n. We have summation x minus x dash all power 2, which is 48, and the standard deviation is 4, and we want to find the number of values m. We have the rule, the standard deviation equals the square root of summation x minus x dash all power 2 divided n. We have the standard deviation 4. And we have summation of x minus x dash all to the power 2, which is 48. But the number of values are unknown. We want to get the number of values. To get the number of values, 4 equals square root 48 over n under the square root. If we want to get the number of values n, we have to remove the square root. How can we remove the square root? We can remove the square root by squaring both sides. By squaring both sides, we will get 48 over n equals 60. By squaring both sides, we will remove the square root, and by squaring 4 is 16. Now we get the number of values. Then the number of values n equals 48 divided 16. Then the number of values is 3. Again, the standard, summation x minus x dash all power 2 equals 48, and the standard deviation is 4. We want to calculate the number of these values. The number of these values. We have the rule standard deviation equals square root summation x minus x power x minus x dash all power 2, which is 48, over the number of values. The standard deviation is 4. Summation x minus x dash all power 2 equals 48. The number of values is unknown. We want to get the number of values n. By squaring both sides to remove the square root, by squaring both sides, 4 power 2 equals 16, then 48 over n equals 16. Now we can get the number of values. 14 equal 48 divided 16, then the number of values equals 3. Now we have some questions. Choose the correct answer. Number 1. The simplest measure for dispersion is A, the mean, B, the mode, C, the standard deviation, C, the range. We know that the simplest measure for dispersion is the range, which is not the most accurate measure for dispersion. Then the simplest measure for dispersion is the range. The second question, the most accurate measure for dispersion. The mean, the standard deviation, the median, the range. The most accurate measure for dispersion is the standard deviation. Then the most simplest measure for dispersion is the range, but it's not an accurate. But the most accurate measure for dispersion is the standard deviation. Let's have another question. We have two functions. The first function is f of x equals x power 2 plus 1. The second function is g of x equals 5. The question is to get the value of 2f of root 3 minus 3g of negative 1. We will get the value of f of root 3. F of root 3 means that you are going to substitute x by root 3 in the first function f. Substitute x by root 3. Now, x power 2 is root 3 all power 2 plus 1. Root 3 all power 2 is 3 plus 1 equals 4. This is f of root 3. Now we are going to get g of negative 1. G of negative 1. You have the second function g of x is 5. The second function g of x is constant function. Constant function means that by changing the values of x, the function remain as it is 5. By changing the values of x, g of 1 is 5, g of 2 is 5, g of 3 is 5, g of negative 1 is 5. Because the second function g of x is constant. Constant function, again, means that by replacing or by changing the values of x, the function remain constant, still as it is, 5. Then, g of negative 1 is 5. The question is 2f of root 3 minus 3g of negative 1. We get f of root 3 is 4. Then 2 times 2 times 4 minus 3 g of negative 1, and we have g of negative 1 equals 5. 3 times 5. 2 times 4, 8. 8 minus 15. Then the result equals negative 7. Then the value of 2f of root 3 minus 3g of negative 1 is negative 7. Again, f of x equals x power 2 plus 1, and g of x equals 15. F of x means y, g of x means y. Now we have two functions or two different functions. The first function is second degree function. The second function is constant function, f of x. The question is to get the value of 2f of root 3 minus 3g of negative 1. F of root 3 at the beginning. F of root 3 means that we are going to substitute or replace x by root 3 in the first function. X is root 3 all power 2, root 3 all power 2 plus 1. The result is 4. This is the first function, or f of root 3. The second is g of negative 1. G of negative 1 means that you are going to replace x by negative 1 in the second function. The second function, g of x, is constant. G of negative 1 is 5. G of 7 is 5. G of 3 is 5. G of 0 equals 5. Then g of negative 1 is 5. The question is 2 multiply f of root 3 minus 3 multiply g of negative 1. 2f of root 3 is 2 times 4. F of root 3 is 4. G of negative 1 is 5. 3 times 5. Then the final result is 2 times 4 minus 3 times 5 is negative 7. Let's have another question. The second question concerning the ratios or proportion. We have the ratio A over 2 equals B over 3. A over 2 is a ratio. This is the antecedent and this is the consequent. Equals B over 3, the antecedent is B and the consequent is 3. A over 2 equals B over 3. And the question is to get the value of A squared plus B squared over A. A squared plus B squared over A. We have the ratio A over 2 equals B over 3. If A over 2 equals B over 3, so we can say that A over 2 equals B over 3 equals constant ratio, which is M. Then we will say that A, the real value of A, equals 2M by crossing the first ratio with M. A over 2 equals M, then A equals 2M, and by crossing the second ratio with M, B equals 3M. Then let A equals 2M and let B equals 3M. The question is to get the value of A squared plus B squared over AB. A squared, we are going to substitute A by 2M. Substitute A by 2M, substitute B by 3M. After substituting A by 2M, then A squared 2M all squared plus B squared 3M all squared over AB. AB 2M times 3M. Then by squaring 2M, it will be 4M power 2 plus 3M all power 2. By squaring 3M, the result is 9M power 2 over 2M times 3M is 6M power 2, because M times M is M power 2, 2 times 3 is 6. Then we can add 4M power 2 plus 9M power 2 because they are like terms. So we can add 4M power 2 plus 9M power 2 is 13M squared. Don't add the powers because this is an addition, not multiplication. Don't add the powers. Over 6M power 2. So we can reduce this ratio by canceling M squared with M squared. Then the final value of the expression A squared plus B squared over AB is 13 over 6. The final answer. Later